Fordham here, and today we're going to be talking about simplifying radicals, just numbers only. There will be some videos that follow eventually that deal with letters, more specifically variables, and then also combining numbers and variables together. So, quick review of what exactly a square root is. You've dealt with square roots before, but usually you've dealt with perfect squares. That's numbers like 9, 16, 25, 100, numbers that have perfect squares. So, for instance, the square root of 36 would be 6. And today we're going to talk about what happens when you don't have a perfect square. Here I have an example drawn of a square. And we actually have the formula for area here, which is width times length. It's a formula you've probably worked with before, just maybe you don't recall it off the top of your head. But the nice thing about a square is, a factor or rule of a square is all the sides are the same. So really, we can take this formula here and rewrite it as area equals length times length. And if you remember anything about exponents, when you have the same variable multiplied by itself, it's really like saying length squared. So for instance, these are the two questions we might see. The length of a square is 4. What is the area? So what they're saying in this problem is this would be 4, and then over here this would also be 4. And we could just plug it very quickly into the formula. We would just do A equals 4 times 4, which is 16. But what we're going to focus on is the other, like the opposite way of asking the question, where we know the area already, and instead we have to find what the length is. So in this problem, our area is going to be 25. So it's really going to be 25 equals length squared. Now, to get rid of the square root, or the square portion right there, what we do is we take the square root. It basically undoes the square. So in this case, I'm pretty sure we can all figure out the square root of 25, which would be 5. And we could even take that and plug it back into the original problem and pretend that was a 5, and we would get our answer. So the whole reason we do this is we have the area of a square, and we're trying to find the side lengths, hence why we take the square root. So here's an example of a problem you would see. Simplify the square root of 40. Now, we know for a fact it's not a perfect square because it's between two perfect squares. That would be 36 and 49. So, how do we simplify this? Well, what we do is we try to break it down into primes. If you don't remember what a prime is, primes are numbers that are only divisible by 1 and the number itself. So some examples of some primes would be 2, 3, 5, 7, not 9, because remember, 9 can be divided by 3, but 11, numbers like that. So what we want to do is basically break down 40 by factoring. And what we're going to do specifically is we're actually going to make a factor tree. So what this looks like is you break it down, you try to say, okay, what numbers go into 40? What two numbers can I multiply 40 or by each other to get 40? So the first example that comes to mind for me is, well, 4 and 10. So it should be quick at any point. You can just multiply the numbers together and check to see if you still get the original. What we're going to do is break it down until we have nothing but primes. Now, 4 is not prime because I can divide 4 by 2. So we get the numbers 2 and 2. And we do know for a fact that 2 is prime. And then we're going to break down 10. What two numbers can I multiply 10 by? Now, you might be thinking to yourself 1 and 10, and you're not wrong, but we don't want to use that in this example because we would end up repeating the factor tree over and over and over and over. So we actually want to avoid the prime number of 1. So instead, we're going to use 2 and 5. And there's a reason why we're doing this. Okay, you can see we have all prime numbers now. So we don't have to worry about anything else in this problem. What we're actually going to do is we're going to rewrite the square root with those prime factors. So there's a 2, there's another 2, there's a third 2, and a 5. Now, I want to take us back a little bit to the previous example we were just doing. And I'm going to go back to it specifically and look. If you look down here, we had a problem where we said we knew the area of the square is 25. And we were able to take the square root of a number and break it down to 5. Now, in reality, if we were to take the square root of 25, we could actually rewrite that as 5 times 5. See, what we're kind of doing is we're trying to find two factors that are the same. And the reason we want that is we know how to clean those up when they're multiplied together. For instance, 5 times 5 is 25, and the square root of 25 is 5. So we can get rid of it. We can pull it out. So back to our example. We have 2 times 2 times 2 times 5. If you notice here, we have 2 times 2 in the beginning part. Well, last time I checked, 2 times 2 is 4 times 2 times 5. I didn't change anything. It's still mathematically the same. 2 times 2 is 4, times 2 is 8, times 5 is 40. 4 times 2 is 8, times 5 is 40. It didn't change. I just slightly changed the appearance. Now, what's nice about doing it this way is I can actually rewrite the problem as the square root of 4 times the square root of 2 times 5. Well, the square root of 4 is 2. And 2 times 5, well, there's no other numbers to really pull out that are perfect squares, so we're left with 2 times the square root of 10. So what just happened here? Well, what we did was we took the original problem of 40 and we basically pulled out a perfect square. See, 40 is not a perfect square, as we've already talked about. However, there's parts of 40 that we can multiply to get a perfect square and take that out. So this whole time in your math career that you've been learning about perfect squares is actually coming handy right now. Let's do another example, and I'm going to use a phrase after this one, actually, that'll help some of you. So let's try this with the square root of 30. Again, square root of 30 is not a perfect square. I'm going to start off by using my prime factors. I want to just break it down. So let's do 3 and 10. Okay, 3 times 10 is 30, so that works out. 3 is prime, so we're done there. However, 10 is not, so I have to keep breaking it down. 2 and 5. 2 and 5 are prime, so we're done. So what we would do is we would rewrite this as the square root of 2 times 3 times 5. But there's a problem. See, 2 times 3 is 6. That's not a perfect square. 3 times 5 is 15. That's not a perfect square. 2 times 5 is 10. There's no perfect square here. And if you noticed in the previous example, it worked out where we had the same number repeat. But in this example, that didn't happen. We have 3 unique numbers. So in fact, you can't simplify this one. This would remain the square root of 30. Let's try one more example, and this one should work out. Ooh, a little big a number there. All right, so there's a common phrase used when you're simplifying square roots. It's couples go out and singles stay home. And the idea is if you're a couple, you're going to go outside of the square root. If you're single, you don't go out because you don't have anybody to go out with. You don't have friends. It's sad. Now, let's go ahead and apply this to this example. So again, we need to make a factor tree of 450. I'm going to pick the easy one of 10 and 45. 10's not prime, neither is 45. So we can break them down again. 2 and 5. Yep, that's prime, that's prime. All right. I like to cross out the numbers as I use them just because that way I don't accidentally use them again later. 45, that would be 5 and 9. 5's prime, but 9 isn't, so we're going to keep going. We're going to get 3 and 3. We already used that, and 3's are primes. So we're going to rewrite this whole problem as 2 times 3 times 3 times 5 times 5. And again, we're looking for perfect squares we can pull out. And that's where this little phrase of couples go out and singles stay comes in handy, because we have a couple of 3's here. Well, what's 3 times 3? That's 9. So we're going to be able to pull out this group of 3 here. And then also we have 5 times 5, which is 25, another perfect square. So we can rewrite this problem really as 2 times 9 times 25. And since we know the square root of 9, this really becomes 2 times 3 times 5, which when we clean it up, 3 times 5 is 15 times, and the only thing left behind is the square root of 2. So that's how we do it. Thanks for watching.